Hi, my name is Alex Gutowsky, and I'm here with Collin, Danyal, Sean, and On to introduce you to our Capstone project, CarBnB. This project was sponsored by Michael Howard, a PhD student here at PSU, and it is the initial framework for a system that allows users to share electric vehicle charging outlets with other drivers. So the problem we are looking to address is the fact that electric vehicle charging infrastructure is not universally accessible for everyone. Publicly available charging outlets are usually few and far between, and the anxiety surrounding when and where one can charge their vehicle is often a large deterrent for people from purchasing electric vehicles in the first place. So Michael had this idea for a system that would allow electric vehicle drivers that installed electric vehicle outlets to share this resource with other drivers, and this would greatly expand the existing charging station network infrastructure, especially in areas where companies do not have much financial incentive to install public chargers themselves. And the best way to illustrate the system would be with a demonstration. So here we are with the production site for CarBnB on the left, and on the right side is a terminal that I'm going to use to emulate two electric vehicle chargers. I'm going to give them the aliases of Garage 1 and Garage 2, as well as provide an associated email address here. I'm going to hit enter to run the script, and we can see that the two devices are now ready to register. So I can head over to CarBnB, click on sign in to sign in with my Google account, and then head over to register a new device. Here are the parameters for the first device. I can click on submit and see on the right side that it was successfully able to communicate with that device. Now we can do the same for the second device here. Here are the parameters for the second device. The only thing I changed was the alias is now Garage 2, and I'm going to have the initial availability set to unavailable. Click on submit, and we can see that it successfully communicated with that device as well. From here, we can go up here to view my devices, where we should see a list of both devices. And we have a few options on the right. We can select this hot swappable availability, so we could set this to available. Establishing that communication with the device on the right side, and we could also click on edit and edit some more parameters. So maybe Garage 2 is now Garage 3, and we can update the rate as well. So we'll charge $2 per hour for this charger. The device is modified and parameters are updated on the right. From here we can actually go to the home page and do a search. So I'm going to provide this with an address, and this is a radius in miles, so I'm going to have a 10-mile radius from this address, and click on search. And we'll see the two devices that I registered here. So we have one for $1 an hour and one for $2 an hour. So I'm going to go for the one for $1 an hour, and maybe reserve that for 2 hours. And this is done in an instantaneous mock fashion for the demonstration, but this would be the point where a device is reserved so you can arrive at its location and begin charging. So I'm going to click on reserve, and it establishes that communication with the device on the right, and a charging session is now logged with a cost of $2. And we can see that it initiated and finished a charging session instantaneously and charged the user the 2 USD. So from here we can go to view my devices, and that was Garage 1 that we charged at, so we can go to the history page and see that for history of Garage 1, here is the date, the time, and the associated price as well. Finally, we can go to view my devices to this edit page, and if we want to deregister a device from CarBnB, we can simply select this delete. Device was deregistered. We could do the same for this. And that completes the demonstration for CarBnB. So I'm here with my team. CarBnB is a web application, as you saw, that allows users to register already existing charging infrastructure and share it with others on a centralized platform. A little about our end users. They're broken into two categories, the producers and the consumers. The producers are the users that already registered a suitable charging outlet and are making it available for other consumers. The consumers are the ones that are utilizing the charging infrastructure, or CarBnB, to locate and utilize the charging infrastructure provided by the producers. And some users may exist in both categories, and we also assume that they could fluctuate between categories, so they can deregister and register charging outlets and also search for charging outlets whenever they would like as well. So CarBnB was designed to be used on both desktop and mobile browsers on the go, as well as at home. So our main features that we implemented were the abilities to register and deregister devices, the ability to modify the attributes of the devices, to search for the devices in the range of a location, to initiate the charging sessions, and the ability to view the charging session histories. And I'm going to pass this off to Daniel, who will walk us through a little bit more about the register.
Hi, I'm Daniel. I worked on the front end, and here's what I did for the register page. So we have these fields for the user to enter their information. All of them are required and can't be left empty. For rate, I have input validation to make sure the user can't enter negative numbers, and the minimum value they can enter is 1 cent. When the user submits the form, the submit button will then be replaced by an unclickable button that has a loading spinner animation inside it, because we don't want the user to be able to submit it again while we're sending the post request for register. When we get the response for our request, it'll show the user if the device was registered or not. If the request failed, then a red modal is shown saying device failed to register. If it was successful, then it'll show a green modal saying device registered, and when the user closes the modal, they'll be sent back to the home page. In the My Devices page, there is a card for each of the devices of the user. This is done using React Bootstrap components, just like the register page. The user can click on Edit. That will take them to the Modify page, which looks like the register page, except that all the fields are pre-filled, so that the user doesn't have to enter them all over again every time. They can also view the history of the device and change the availability. When the user changes the status, the select menu becomes view only, so that the user can't change it again while the page is waiting for the response of the status change request. If the change is successful, a green alert will be shown at the bottom of the page saying it was changed successfully. If it failed, then it will show a red alert with a message telling the user that it was unsuccessful.
This is Collin speaking. For the searching page, it works pretty simply. On our home page, we have an address bar and a radius. And when you hit the search button, this will be sent to the back end where an API call is made to validate the address. And in return, a lot of information is returned, but we use the geohash of the address that is given to the back end to create a search query with the radius. So you take the radius and the location and you find all matching geohashes within the radius, and that is returned and presented to the user through these cards. And if something is available, then the user can reserve it, and if it's unavailable, then the user cannot reserve it. But once the user hits reserve, then it goes on to our next section.
I'm on, and I added MQTT interaction to our app. It connects Cloud Functions and local script emulating edge devices. We use MQTT as a lightweight messaging protocol, enabling efficient system communication. We linked both Cloud Function and scripts to Eclipse Mosquito MQTT broker URL. In both, request and response MQTT clients were set up for interaction. Specific MQTT topics were created for messaging. The console displays the emulator script. It's initiated with device alias and email. Once active, Cloud Functions and script communicate. For instance, during device registration, the script verifies and responds. Also, the initiate charging function sends alias and hours to the script, which calculates the price and replies. This interaction is similar in the update device Cloud Function. MQTT ties both Cloud Functions and the script together. I'm passing it off to Sean.
Hi, I'm Sean, and I'll be talking about the backend history page. So when a user finishes charging their car, it will send a history of the charging session to that device, and that'll be stored in the database inside of a sub-collection of the device. The history will consist of a date when the charging session happened, as well as the price, which is the rate at which they're charging times the number of hours. So queries in Firebase, which is the database we're using, are shallow, meaning that when a page asks for information about a device, it won't automatically get the device's history in case that subcollection is very large. So you need to explicitly ask for that. Also, when the devices are deleted, it will go through and delete the history as well.
So, some additional achievements our team had with the project was integrating the Google Cloud Maps geocoding API and Google Authentication. Geocoding is what allowed us to validate user addresses and convert them into geohashes, which made searching for electric vehicle chargers much faster than complex chained queries. And Google Authentication allowed users to log into the site, and secure routes protected user data. This was initially a rejected feature for the project, but to avoid a lot of the technical debt we were accumulating early on, we changed our minds and integrated it into the project with great success. So now let's talk a little bit about the architecture of the project. This project uses a lot of services provided by the Google Cloud Platform. First, the users of CarBnB access the website that is hosted on Google App Engine by using standard web browsers. This retrieves JavaScript files that are stored in an S3 bucket and returns them back to the web browser to render. The user can now navigate around the site, but certain functionality that interacts with the backend services must make a request through Google API Gateway, where we have a host of cloud functions that define our API. These functions interact with the database, creating, deleting, and updating records, but they also publish and subscribe to topics using a service called Google PubSub. The edge devices are also listening to events on the PubSub and will update the parameters of itself when it receives a message, and it also will return back a response. After the API is done processing a request, it can return a response message back to the web browser to display to the user. Now, a bit about our team's development process. We followed the agile software development paradigm, breaking down the requirements of the project into 2-week sprints and iterating on those features using the feedback we received from our sponsor. We developed our sprints in a way that they logically follow one another. This could be seen if we actually step backwards through our sprint cycles here. So in order to see the histories of charging sessions of a device, you should be able to have the ability to begin and end a charging session. And in order to begin and end a charging session, you should be able to modify the state of that device. And to modify the state, you should be able to register that device in the first place. And then finally, at the end, we did our final cleanup of the project, doing the final styling with CSS, writing the documentation, and getting the project ready for that final delivery to the sponsor. And now this schedule, we now realize, assumes that all of these tasks will take the same amount of time and effort, but registering devices and histories was pretty straightforward, but our team really struggled with the modify and the sessions. So some sprints blended into one another, but we really tried to maintain this linear path forward to project delivery to the best of our abilities. A little bit more on our development process. Our team of 5 was structured into a full stack development team. Collin and Danyal worked on the front end, developing all the web pages, making those API calls, and displaying all that information to the user. Sean and An developed our API functionality, with Sean working on the interface with the database and An working on the PubSub and edge device client. I steered the overall direction of the project, as well as writing up that documentation, reviewing the pull requests, gathering requirements, and leading the discussions with our sponsor. So moving on to unexpected events. Not everything went smoothly with our project. The first hurdle was the deprecation of this service in Google Cloud Platform called Google IoT Core. This service was deprecated during development, and it would have been a very nice service to communicate with physical edge devices rather than an emulated script. And unfortunately, we never did get a working replacement for that service to facilitate the communication with physical devices. But in the interest of pushing that area of the codebase forward in any meaningful way that we could, we instead developed a script that emulated the functionality of an edge device. This script is not at all what the intended use case of CarBnB was, which was to interface with physical devices installed on an electric vehicle charger, but nevertheless, it still pushed that area of the codebase forward for our sponsor. And another unexpected event was simply the quirks of a non-relational database. Our team all learned in university how to interact with a relational database, and we understand to some degree the limitations and strength of that relational system, but with non-relational, it took some getting used to. We had to discuss a lot about how to efficiently organize and store the data we had, and it took a lot more testing and research than we initially anticipated when we started the project. So, sponsor feedback. What our team did well. Our sponsor appreciated the professional communication of our team, as well as our creative solutions to the challenges we faced. Our sponsor reported that our team could have had a more consistent meeting schedule with them, and would have loved to hear more input from all of our team members during the meetings. Our sponsor's next step with our software is to automate the deployment of cloud services, either with Google Cloud Platform or an alternative like Amazon Web Services, as well as tackle the physical edge device integration that our team struggled with. The long-term plans include payment processing through Stripe. So, lessons learned. We learned to start early, to iterate often, to not let perfection be the enemy of progress, to get a working solution out there as soon as possible so you can review it with your team. Building up a code base from scratch is difficult if you're not careful with your design. Do not reinvent the wheel. If you find yourself writing out complex designs for common problems, like how to calculate the distance between two addresses, you are probably reinventing the wheel. The communication is vital. For team leads, it's important to be clear with what needs to be done and when it needs to be done. And for software engineers, it is important to communicate if something is unclear or if you are facing major difficulties. If you've made it this far, we sincerely thank you for watching. We would like to thank Michael for this amazing learning opportunity, Bruce for his guidance throughout this entire process, Wu Cheng, who is the professor that teaches cloud technologies. He helped us with the project in its very early stages. And we would like to thank the other Capstone teams as well for all of their advice and guidance. Again, thank you, the viewer, for watching, and have a great rest of your day.